This lab is to use a SAR to control a small DC motor. The circuit for this lab is quite simple, but here to make the waveform more clear, I used a 10K port and a 0.47 microfarad capacitor, and I used a 100 ohm 25 watt resistor. Now let's look at the waveform. For the blue one, it is the waveform for the power supply. Here we use a transformer to supply a peak-to-peak voltage of about 20 volts. And the yellow one is the voltage drop on the SCR. Now you can see before the SCR turned on, all the voltage is dropped on the SCR. Then after the SCR turned on, the voltage drop on the SCR will drop to nearly zero. The difference of these two waveforms is the waveform for the load. When the SCR's voltage drops to zero, then all the voltage supplied will be dropped on the load. If you want to change the Farring delay angle, you can change the resistance of the part. Here you can see if I decrease the resistance of the part, the current will increase so that it will satisfy the required firing current for the SCR early. Then the Farring delay angle will be small. So now you can see the resistance of the port is nearly zero, and then the Farring delay angle is also nearly zero. If I increase the resistance of the port, then the current will decrease. So the Farring delay angle will increase. And if you change to another capacitor, now I changed a capacitor to 47 microfarad. Now you can see the Farring angle can be delayed to more than 90 degrees. Now you can see the Farring angle is more than 90 degrees. And also as you increase or decrease the resistance of the port, the Farring angle will also change. And if I change the load to a small DC motor, you can see we can use this SCR to change the speed of the DC motor. So now you can see the load, the difference of the blue one and the yellow one is small, so that the speed of the motor is also slow. However, if I decrease the resistance of the port, then you can see the load will increase, so that the speed of the motor will also increase. If I increase the resistance of the port, then the voltage drop on the load will decrease, so that the speed of the motor will also decrease. If I increase it,